So today we're going to be looking at various methods of taking input into our Python applications, and we're going to look at some of the challenges that come with that. And the reason why we want to do this is because a lot of the time, as you've been developing your programming skills so far, you've either had to give the data in as kind of hard-coded variables defined in the code itself, or you might have had to take some user input. But either way, neither of them are particularly helpful if you want to work with a big database, you want to work with some data that's a massive data file that's stored on your computer somewhere that you want your program to process. You don't want to have to put that in every single time you run the program. You want the program to be able to take that from your computer, read it in, and then use it. So that's what we're going to be looking at today. And this is kind of the start of starting to build some really powerful functionality. So we're going to start with file reading. Kind of the basics really of this sort of thing. So we want to read a file, we want to take a file and get that data in the file into our program. And Python has functionality to do this, particularly for text files. So we're going to demonstrate it here. So when we want to read a file into Python, we can use the open function. So this is telling Python effectively to go to our computer, to go to that location and open that file. So you can kind of see we've got my file structure here, and you can see I've got this data folder here, and in the data folder we've got various different files, one of which is test.txt. So what this line is telling Python to do is it's saying go into the data folder. So Python's kind of operating from this notebook here, which is outside of the data folder, it's in the layer above. So this tells Python go into the data folder and find test.txt. So this bit here is telling Python the file that we want to look at. And then this second bit here is telling Python we want to read the file. So you can decide, you can specify different methods by which the Python is going to look at the file. In this case, we're going to read it because we want to read in data from the file. So we can go ahead and run that, and that should all be good. Now, we've opened the file, but we don't have any data yet. So to read the file, we call the read method. So what we do is when we call open, we create this kind of variable test file, and that kind of stores all the information that Python needs to know about that file. And then we can use this test file variable, and we can call .read on it, and that's going to allow us to kind of take the data that's in the file, the text data, and put that into that variable called data. So we'll go ahead and run that, and that's all worked fine. And then we can go ahead and print the results, and we can see that it says this is a test message. And if we go ahead and check the actual file, we can see this is a test message. We've successfully taken the data from the file, imported it into our program, and printed it out. So we can read from a file. Now, an interesting thing to note is we try and read from the file again. So we're going to just call testfile.read again and see what happens. Essentially the same code, and it seems to print out nothing. Why is this the case? And that's because Python remembers what position you are. So remember when we said Python is going to create this test file object here to store that information. One of the things it stores is where in the file you've kind of read up to. So when we call .read, Python is going to take all the data in the file and is going to read all the way up to the end. So when we call .read again, Python knows it at the end, so it's going to start at the end and finish at the end and read nothing, and that's why it prints out nothing. So that's something to bear in mind when you're playing with code or working with code like this. If you call .read twice on a file without resetting the position that Python's reading from, then it's just going to print out nothing because it's already at the end of the file. So Python does allow us to change effectively kind of where we are in the file. So you could think of this kind of like a bookmark. When Python reads, it takes its bookmark, it puts it through the pages of the book, and then puts it in where we finish. And what we can do is we can change the bookmark effectively to tell Python where we want it to start reading from. So seek can take two arguments, so kind of two parameters, offset and whence. So offset determines how far or backwards we want to move the bookmark. So you could put an offset of 10, and it might move it 10 steps forward. Put an offset of -10, it will move it 10 steps backwards. And the whence argument determines from where we move the bookmark. So it kind of determines relative to what position are we moving. So with 0, we're moving from the start of the file. So if we said an offset of 10 and whence is 0, then it's going to go 10 characters into the file and then start reading. If we say 2, it'll be the end of the file. So if we said 2 and -10, it's going to go to the end of the file and then read from the last 10 characters of the file. And if you do from 1, it's going to move from the position of the bookmark, so where it currently is. So using seek 00, because we're already at the end of test file, we've read to the end, seek00 should tell it to move the bookmark 0 places from the start of the file. So effectively, it brings us back to the start of the file. So we can go ahead and run that. And that all works fine. And then we can read the data again just to check it's worked, and we can see it prints out this is a test message as we would expect. So we've effectively told Python we want to go back to the file, back to the start of the file, and it's gone back to the start of the file, and we can see that's all worked successfully. And just as an example, we could also seek to the middle of the file. So this is taking the parameters 8 and 0, so that's going to say go to the start of the file, go 8 characters forward, and then begin reading from there. So go ahead and run that, and you see it prints out a test message. It skipped the this is, and obviously the spaces are included as characters as well. So that's why it cuts off those 8 characters, or effectively skips past them, reads from that point to the end of the file. Now the last thing you need to do when working with files in Python, and this is particularly important, is you need to close them once you're finished. And this is kind of similar if you've ever been like working in a Word document or something like that, and it won't let you kind of close Word until you've saved the file or told it you don't want to save the file. It's kind of similar when your computer opens a file, it kind of stops other applications being able to look at that file to make sure that 2 applications aren't trying to edit it at once or like close it at once. So you want to make sure that the file is closed once you're finished with it. Otherwise, you can get some kind of funky behavior. And a lot of the times when something goes wrong when working with files, it can sometimes just be you've forgotten to close the file and then you try and open it again or something like that, and Python gets a bit confused because you're trying to open a file that was already open. So you go ahead and close it, and that's all fine. And you can kind of see that it's closed because if we try and read from it, now that it's closed, we're going to get an error because we're reading from a file that's been closed. So again, another thing to be aware of, if you close a file early and you get an error that looks a bit like that, like IO operation on a closed file, chances are you've closed it a bit too early. So that's just a handy hint when you're debugging your code. Now, fortunately, Python provides actually quite a nice way to encapsulate this functionality or package it up using these special operators with and as. So what this will do is if you say with and then you specify the file you want to open, similar to as we did before, and then you specify as the test file, so that's kind of telling it we want to do this function, open this file, we want to call it test file, and then Python will indent, or you'll be able to indent the code within. And what Python does is it knows that while you're in this indented bit of code, you want the file to be open, and as soon as you exit out the indented bit of code, you want to close the file. So there, we can run that, and you can see that that works perfectly fine, and that's because, and this has also gone ahead and closed the file. So I could also take this and put it below, and if we just define, it might give an error saying that it doesn't know. There you go, it gives the right error, operation on closed file. So you can see there that it prints it out on this line, and then outside of that indentation, the file's been closed automatically by Python, so we can't read from it. So that's something handy to be aware of, because it makes any file operations a lot more clear as to when the file's being used and when it's not. Because obviously when it's indented, you know the file's open. When it's not indented, the file's closed. Saves you having to make sure there's like a file open and a file closed somewhere later. So that's all well and good. We've kind of seen how text files work. Now another thing we want to read in is binary files. Now for the purposes of this, binary just means kind of any sort of data that isn't text data. So this could be stuff like images, this could be stuff like audio, this could be stuff like video. So anything that isn't data really, or anything that isn't text, sorry. Everything is data on a computer. So what we're going to do now is we're going to kind of use the same file again, but we're going to put it into binary mode. So if you remember from the start, I said that when we're using this open function, we can specify different arguments that we want to pass in. So we originally specified just the R argument, which stands for read, and now we're going to put in RB. And this says read binary to Python. So we're not telling it we want to read like text characters, we want to read binary data. So we can go ahead and do this. And this function here, or this bit of code, will show us that we read in the data, and it prints out, this is a test message, but it prints out a B beforehand. And this is Python's way of telling us that this data is binary data. Python's quite clever in the fact that it understands that what text data looks like in binary. So it automatically kind of prints it out as text because it can convert the binary data into text kind of automatically, but it appends that little b there to tell us this is actually binary data. You can see when we print the first character of data, if you kind of remember how indexing works from last week, it tells us 84. So if it was text data, you'd expect that to say T. But because we've read it as binary data, Python prints it as kind of the numerical representation of T as the computer sees it, which is, in this case, 84, is how kind of the computer views a capital T. And you can see when you print the type of data, so we're asking Python, what sort of data is this? It tells us it's bytes. So that's kind of binary data and not a string, which would be text data. So you can see, although kind of the output might be a bit misleading, this is in fact, Python is seeing this as in fact as binary data rather than text data. So yeah, and binary also allows us to do some extra cool things with like the seeking in the file. So with text data, you're only able to seek from the start of the file. Binary data allows us to seek from the current cursor position and from the end of the file as well. So it allows us to move forwards and backwards a little bit more. So we can kind of go ahead and do that. And you can see that we've read from the end here with the argument 2. That tells Python to start the end, and then -5. So we've gone 5 characters back from the end, and then read those 5 characters again as binary data, because you can see that little b is appended to the front there. That's Python telling us that although it looks like text, Python is going to treat this as binary data. So another thing to be aware of if you're dealing with like different data formats, just make sure you're clear on like when it's text, when it's binary, and you're using the right sort of arguments or commands to deal with either. So we've seen kind of how to read from files, but equally useful is writing to files. So in a lot of applications, you might want to read in some data, you want to process it, and then you want to output or export that data to a file type to save it. So we need to read the data in, but we also need to write the data back out again. And there's a lot of different ways we can do this. So I've got a little table here that kind of goes through the different modes that the open function uses. And there's interesting differences between them. So we've seen read, just reads from the file. Write will write to a file, and it can create files, and it also overwrite files if they already exist. That's something to be aware of. If you're kind of working with a file and you accidentally specify the W argument, you might accidentally overwrite that file instead of kind of appending to it or something like that. X will write to a file, but it'll error if the file exists, so it's a bit safer. It means you're not going to accidentally overwrite a file that already exists. You're only going to create new files if you need to. A will append to a file. This will create and overwrite files. So if a file doesn't exist, then it will create that file. But if a file does exist, then it should append to the file, so add text or whatever data you're putting in afterwards. And then B and T are used kind of after one of these arguments to specify whether it's binary mode or text mode. We've already seen that with the R argument and the RB argument. And then plus is kind of a special character. This allows us to kind of do both. So if we use R+, that'll allow reading and writing. And if we use W+, that'll allow writing and reading. One thing to note is if we do R+, then I'm pretty sure Python won't overwrite files that exist, where if you do W+, then it will, because the W, when we're specifying W as a write method, it's told to overwrite files. So just another thing to be aware of. So we're going to use a file called test2.txt. So this one already exists. But we can kind of show how the W method is going to work here. So you can see it's already got some data in there. We're going to go ahead and write some text data to this file. And you can see that it's overwritten the data that was already there and replaced it with the text data we told it to write. So you can kind of see it's working as we expect. And again, we can use some different text, and again, it will change again. One thing to note, as I said, if we go ahead and just delete the file, and then run this again, we should hopefully see that it goes ahead and creates the file and puts the text in it. So again, if the file isn't there, it will create it. If the file already exists, it's going to overwrite it. And then in this instance, let's try appending instead. So going back to the table, what we'd expect it to do is append the text we've got, so and writing files, to the end of the file. If we go ahead and run that, you can see that it's appended that text there. If we go ahead and run it again, it's going to go ahead and do it again. So you can kind of see the difference there between writing and appending, kind of whether you're creating a new file or adding to an existing one effectively. Now, there are many instances in Python where we might want to read a file in parts and process each part separately. And this is particularly pertinent with comma-separated value files. So this is quite a common format to store rather simple kind of sets of data. And they're kind of used in a way to, you can kind of see an example here where you have like these header columns. It's almost like a table in kind of code format. So you have these headers, name, student number, and course, and then the data for each row. So you could have John, student ID, and biology. So what this format does is quite helpful because each value is separated by a comma. So when we're reading it in, we know to kind of read one line. That will give us the header, and then every subsequent line of data is every subsequent kind of row is a row of data in the table, and we can find the different attributes of data by looking for the commas and kind of splitting them apart. Now Python is very helpful because it has a read line method, which will read one line in at a time. So it kind of does that first step for us. It's able to just read in one line at a time, and then we can deal with just processing each line. So on here we've got testdata.csv, which has some just simple name and society for people who are running this last year actually. So we can go ahead and open that, and we're going to use R+ mode, which allows us to read and write to the file. And then we can go ahead and read a line. And we've got a little bit of extra code here. Firstly, one function here that will strip the new line character. So in your computer, when you're writing text files, at the end of every line, it appends like a kind of a hidden character that tells the computer we want to move on to the next line. So you can't see it when you're looking at it in kind of like a window like this, but in the underlying data, there's a little character about here-ish that's telling the computer, go on to the next line, don't carry on writing text on this line. And what we're going to do, we're just going to get rid of that because we don't really need it. So we're going to strip that out, we're going to remove it, and then we're going to use this .split method. And what this will tell Python is it says, look at the string. So in this case here, name, comma, society. And the split method says, I want you to find all the commas in that string, and I want you to kind of split the string up when there's a comma. So it will return a list of strings. So the first entry should be name, and the second entry should be society, because we kind of split it on that comma. This is very handy for processing CSV files because, as the name suggests, all the values in a CSV file are separated by those commas. So if we're able to split a line according to the commas, we can effectively take our data and put it in a nice list format, which hopefully you should all know how to work with from last week's session. So we can go ahead and do this, and we can print out headers, and you can see it puts it in that nice list with name and society as the first and second entry in the list, respectively. And we can also do a bit more complicated stuff with this. So we're going to use a dictionary, which I think we covered last week, and we're going to use a while loop to make sure that we've read until the end of the file. So I'm just going to go and kind of explain this bit of code a little bit, highlight the various interesting things. So firstly, we define the dictionary, and then we tell it we're going to read in a line of the file. So we kind of create this variable line, and we do the same method as we did before. We read the line, we remove the new line character because we don't need that, and then we split it by the commas to get the data in a nice array or a list format. And then we do this while loop here, and we say, while the line doesn't equal the empty list or empty string. So we know that once we get to the end of the file, there's not going to be any data there. So the line variable is going to be an empty string array because the CSV file is going to read in kind of an empty string. We're not going to remove any new line characters. We're not going to be able to split it by anything because there's going to be no data there to split it by. So we're just going to return kind of an array with an empty string in it. So we know that that means we've reached the end of the file. So then what we're going to go ahead and do is we're going to put our data into the dictionary. And because we're aware of kind of the format of the CSV, we can specify that the key for our dictionary is going to be the name and the value is going to be the society. So if we go back to the data file, you can see each person has a unique name, and each person has a society. So the key for our dictionary is going to be the name, and the value is going to be the society that they're part of. And then we go ahead and read the next line in, kind of rinse and repeat with the while loop, and then print out the resulting dictionary. One thing to note is we've already read in the header line, and Python's keeping track of how many lines we've read in. So we're not going to reread that header line in. But if you're doing this yourself in kind of one kind of complete block, you'd have to first process that header line. In this case, you might want to just remove it because we're not using it for the dictionary, but in other cases, you might need to do some processing with the header line. But yeah, so just one thing to be aware of, that Python kind of keeps track, like when we were reading it, kept track of where we were in the file. It also keeps track of how many lines it's read. So it's going to read from kind of, in this instance, it's going to read from the second line all the way to the bottom as we go through the while loop line by line. So go ahead, run that, and you can see it prints out a nice dictionary with everyone's name and their respective society in the dictionary. And we can just check that this has worked. We can print out the society I'm from, and it says Warwick AI. So we can see that it's correctly read the data from the file, but more importantly, we've been able to take that data and put it into a more useful data type for ourselves. We've put it from just kind of text data into a dictionary, which is potentially a bit more useful. So yeah, you see that we can able to take a CSV, pass it in to our code. And then we can also look at how you might want to write a line. So unfortunately, Python doesn't have a built-in write line method like it does the read line method. But as I said before, that new line character is going to come in handy here because we can kind of put that at the front of the text we're going to put onto the file. So I can go ahead in the file here, and I'm just going to remove myself from the list. Actually, no, let's add Laura, our marketing officer, also part of Warwick AI. So we've got the new line at the front, and the reason why we're putting the new line at the front is because at the end of this file, depending on how the file's structured, there might not be a new line. In the case here, there isn't. So we're putting that new line on the front to say, go on to the next line and then write this line of text. And CSV files are fundamentally just text data in a special format. So we go ahead and write this. It'll tell us how many characters it's written. That's the output there. But if you go back to the CSV file, hopefully it should update. Potentially not. Yes. So this is a little key trick here, is we haven't closed the file. So if you go ahead and close the file, then we should see it's updated. So another thing to be aware of is obviously if you haven't closed a file, as I said, it'll cause an issue with whether something will be there or not, whether your computer will be able to see the changes. So Python kind of stores the changes outside of the file, and then waits till it's closed, and then it updates it for the whole computer. So that's why before we closed it, we couldn't see a change. After we close it, we can see the change. So again, another thing to be aware of, it's very easy to fall into the trap of like doing a load of file kind of changes, then looking at the file itself and being like, where's it all gone? What's happened? You just forgotten to close it. Easy mistake to make, but fairly easy to fix, fortunately. So that's a lot of kind of information on how we can kind of use files, how we can read in from files, write to files, and specific file formats that you might want to be aware of. Another really powerful piece of functionality in Python is command line arguments. Now these are a little bit more complicated, but effectively we can run programs from the command line of our computer. And in the case of Visual Studio Code, you should be able to open up a thing called like a terminal here. Might look a bit scary, completely fine, but this can allow us to do some quite powerful sort of scripts. So at the moment, all the stuff we've been doing has been kind of in these notebook formats, and that could be quite helpful when you're kind of playing around, you're learning how to use the code, you're learning how to code a certain piece of functionality, but sometimes you might just want a simple kind of file, an executable that you can just run, and it'll go ahead, it'll take all this data, process it really quickly, and spit it out in the format you want. You don't have to be going through a notebook and like running each cell one after the other, waiting for it to do this, because ultimately programming is designed to make a lot of these more boring tasks automated a lot quicker, a lot faster. So command line arguments are where you kind of run a program from the command line. So for example, Python is a program that we can run from the command line. And there's a couple examples here. So we can pass it an argument, Python-C, and this will tell Python to execute a bit of Python code. So an example I've got here is just print hello. So you can see that this is hopefully fairly familiar as kind of in these double quotation marks, we've got a bit of Python code that's just going to print out the word hello. And when we click enter, it's going to kind of effectively run that piece of code, run that program, and print out the word hello. Another argument we could specify is -v, and that's going to give us the version of Python we're using. In the case of myself, it's Python 3.8.8. So you can see different arguments can specify different behavior for the piece of code that we're running. And this can be really helpful when we might want to create a Python script, and we might want to use it in a manner to kind of, in a way that we can change the functionality of the script without having to change the code. We just pass a different argument to it. In this case, it was the difference between -c and -v, and that will change the way that the program or the script operates. So it means that instead of having to generate or code lots of tools that do very similar things, we can code one kind of master tool that can process data in a variety of ways, and when we go to run it, we can just pass it the correct kind of parameters, almost like we're using a function call in Python, and it will process the data in the way that we want. So I've got a couple of examples here of kind of code that works like this. So I'm going to go ahead and talk through how this code works, and hopefully you'll be able to see kind of the process that's used. So this is a kind of simple program. I'll just give a quick demonstration of running it that allows us to kind of take in some input and modify the input in a certain way. So what it's going to do is we're going to take in kind of some input, which will be just a username, and it should just print it out if I've spelt it correctly. Should be there. I think it's there. We'll try command line arg1 and see if that one will work. Hang on a minute. There we go. I was in the wrong file. One thing to be aware of with command line is you have to kind of move around the directories. We won't cover too much command line in this case, but if you're just using stuff in kind of the home space of your Visual Studio Code, you shouldn't have this issue. It's because we're working quite a complicated kind of setup here with all the different weeks. So this function, this program will effectively take in a username and it will do something to it. It will just say, hello, Alistair. So let's have a look first at what that specific bit of functionality is doing. So firstly, we import a library called the system library. Don't worry about this too much now. Kind of libraries and stuff will be covered a bit later on. But effectively, a library is just some extra functionality that Python doesn't like come with automatically, but when we tell Python we're going to use this functionality, Python's able to kind of make use of it. So the first thing, what this system library does is it stores in the arguments that we're passing to the Python code, effectively to the Python program, in fact. So the first thing, the first argument is always the running program. So what we did, we took that argument in, we read it in, and we printed it out. And the first argument is the running kind of program. So in this case, we told Python to run command line arguments.py, and it printed out that that was the case. That's the program that we're running. The second argument we took in was this username. So you can see the first one 0, second one 1, kind of list indexing, as you saw last week. And that's going to take in our username and then store it in this variable here. And then at the end, it's going to print out the username there. So a fairly simple program so far. But what makes this program a little bit more powerful is the ability to put in some arguments, like we saw. So if we go ahead and kind of set up the same thing again, what we've done here, or what I've done here, is I've added a couple of arguments. Firstly, the -u argument, which is going to make the name uppercase. And secondly, the -r argument, which is going to reverse the name that we put in. So we can see that we've created in the script two options, two variables to store these potential options. Now, since they're optional, we can't just go away and try and access the third and fourth entry in sys.argv. So if we hadn't specified kind of these options, then the maximum amount of arguments is going to be 2. There's just going to be the running process and the username. So hopefully you might have found out last week that when you try and access like an element from a list that's out of reach of the list, so if the list is of size 2 and you say I want to access the third element, the program's going to crash because you can't access the third element of something that only has 2 elements. So we need to make sure that we're checking, firstly, is there more than 2 elements? So effectively, are there 3 elements? And if that's the case, then we can store option 1 as that third element. And we know, because in this case, the maximum amount of arguments we can have is 4, we can then go ahead and check, have we got 4 arguments? And if that's the case, we can go ahead and store the second one in option 2. So just something to be aware of when you're dealing with like these command line arguments is that you need to make sure, especially if you're using some optional stuff, that you're not going to try and access them when they don't exist. So it's like a simple if statement just to check how long is our number of arguments will kind of suffice in that regard. And then we've got this if statement here that's going to kind of perform our different functionality. So firstly, we check is either of the options -u, so the uppercase argument. And if that's the case, then we're going to set the username equal to, we're going to convert it to uppercase and reset it, so that's going to make the name uppercase. And then secondly, we check is either argument -r, and if so, we're going to use this kind of clever string indexing technique to reverse the name. And then we print out the final result. So you can see that we can do -r, -u, we can do -u, -r, and it's going to give us kind of the same result. We're telling it to do the thing. We could pass in -r, -r, and it will just reverse it. Because again, in that case, you know, both of these options are equal to -r, so it's just going to run this line. We could similarly pass in -u, -u, and it's going to do just uppercase. But effectively, kind of the main crux of this bit is if you have kind of a load of Python code that's able to read in a file, process it in a certain way, and output a result, and you've got like 10, 20 different files you want to apply this process to, but potentially with slightly different requirements for each file, this is a really good way of doing that because you can kind of create your script and then for each file you can specify, or for each kind of bit of data, you can specify these are the ways I want you to process it. So this is a very simple case, but we can say, you know, you can just print it out, you can reverse, you can have it uppercase, and this is all equivalent to basically if you replaced kind of the name there, Alistair, with a location of a file on disk, took that file in, processed it correctly, wrote a file to the correct place, the correct output. This can start building some really powerful processing functionality and make a lot of kind of jobs that would otherwise take a long time quite simple and quite quick. So this part of the notebook just goes through kind of all of that code in a bit more detail. And I'd recommend if this section was a little bit more confusing, please do ask any questions and take a look at the notebook. It should be available on the Google Drive, and you'll be able to kind of work through it there. So that pretty much sums up the main bulk of the content for this week. So just to kind of summarize, we talked about, first and foremost, how to kind of read a file in from disk, from the computer, with the .read method, as we kind of saw here. We talked about seeking in files, so how to kind of reset our bookmark back to the start of the file if we need to. We talked a bit about the with as kind of setup that automatically closes the file when we're finished with it, so it saves us from having to remember to close it. With Jupyter Notebooks, it's a bit less useful because sometimes you want a file open across multiple cells, and because of the way they work, the with as operator or the with as kind of setup always has to be done within one cell. But if you're doing any scripting, like we saw in that command line arguments file, like kind of something similar to this, with as is a lot more useful because you're not kind of limited to the single cells as much as you are in Jupyter Notebooks. We talked a little about binary files and kind of the differences, effectively just a different data type, but allows us to do a little bit more with the seeking. We talked about file writing in terms of the difference between writing, which overwrites, and append, which will add text to the file. And we talked about CSV files, so looking at kind of taking in data one line at a time. This is a really, really common file format. I've seen this countless times, so really a good one to kind of get familiar with. And then we talked just at the end about those command line arguments, which allow us to kind of take all the code that we've learned about in Jupyter, put it into one Python file, and then run it and able to change that functionality really nice and quickly just by specifying in the command line which kind of arguments we have, which functionality we want to use. So yeah, that's pretty much summarizes the week. Now, because this whole week has been about file reading and writing, for the exercises this week, they'll be just at the bottom of the notebook, but they're also going to require you guys to download some data as well, because a lot of it's going to be about reading in data and writing data. So just make sure that you've got the notebook on your computer for the exercises, but you've also got these various different data files, as these are all important for kind of solving the different challenges in the notebook. And also, if you want to rerun any of the code that you've seen in the notebook, they're also used for that. So yeah, so it's a little bit of extra stuff to download, but it's kind of part and parcel of working with input and output file, input and output, stuff like that. You're working with external data. So yeah, so that kind of finishes the talk.